Hello, everyone. Green concrete, which is the need of the hour, benefiting both durability and sustainability. You know why it is called as green concrete? Because it is environmental friendly and supports the cause of sustainability. How does it support the sustainability? As we have seen nowadays that the whole world is facing a challenge against the weather, against the pollution and floods everywhere, global warming. So the cement industry alone is producing around 8% of carbon dioxide in the environment when we compare with all the industries on the earth. So green concrete is mainly comprised of ordinary Portland cement, which is partially replaced by industrial wastes and all other ingredients being similar to normal concrete. These industrial wastes have very important properties. When they are added to concrete, will enhance several properties of concrete. Cement industries alone, I have already explained you regarding this, that 8% of carbon dioxide is emitted in the environment and it is creating a lot of pollution resulting into global warming and floods. The commonly used industrial wastes, or they are also called as mineral admixtures, are ground granulated blast furnace slag. The short form of that is GGBS, and it is produced from the iron industry. The next is fly ash, which is an industrial waste or the ash, when coal is burnt in thermal power plants. Another industrial waste, which is called as microsilica, or it is also called as silica fume, and ferrous silicon industry. Nowadays, we are also trying to understand another type of waste, which is an ash, rice husk ash. When the rice cover is burnt in industries like brick manufacturing, rice mills, we are able to get that ash. So that is also, acts as a mineral admixture in concrete. Green concrete improves the properties of concrete like reduction in shrinkage cracks. These shrinkage cracks, if cement is more, shrinkage will be more. If cement is less, the shrinkage will be less. Since the heat of hydration is less, because of that, heat of hydration is less, because of that, shrinkage will also be less. Naturally, the cracks will develop, will also be less. Because of that, further the strength and durability is not reduced. When we use these mineral admixtures, there will be reduction in the permeability also. Permeability reduction, since the mineral admixtures or particularly these wastage what we are using, they are finer than cement. So naturally, they will pack even the pores between the cement particles, and they make the concrete more denser, reducing the permeability. Finally, the workability will be enhanced, because since the finer particles will be larger, more in number, since the specific gravity of mineral admixture is very less. They are finer than cement. Because of that, it will be more workable. Because of that, we are able to achieve good compaction. As we know that the compaction is directly depending on the workability. Because of good compaction or 100% compaction, we are able to achieve a denser concrete. And of course, as we know that denser concrete will produce high strength concrete, or it will enhance the durability of concrete. Resistance to acidic attack, any acids, since the ingress of acid will be controlled because of its, the green concrete's dense structure. Resistance to sulfate attack, even the sulfate attack, since the GGBS particularly has ability to resist sulfate. This green concrete is also resistance to fire, reduction in carbon dioxide emission because of lesser production of cement on the earth, corrosion protection. So since it is denser, so it will not allow air and moisture to enter into the body of concrete, and it will not be touching the steel inside. So because of that, even the frost resistance is, as we already know that in the western countries and the cold countries, the concrete will absorb water during the rainy season. It gets frozen during the winter season. The water gets converted into ice, and as we already know that ice has lesser density than water, since its volume will increase. Because of that, the cracks will develop. As we know that already it is a hardened concrete. Within the hardened concrete pores, if the ice formation happens, then it will definitely push the walls of the concrete around and starts cracking, and the cracks further propagate, and big cracks will form, and definitely the deterioration of concrete starts. And of course, since we already know that these mineral admixtures, they control the heat of hydration or the reduction in heat of hydration. Because of that, so thermal cracking will be controlled. So even the flexural strength of concrete will also enhance because of these mineral admixtures. Thank you very much.